Our project is called Documenting the Benefits of Home Energy Retrofits, and we worked with a community partner in Charlottesville called the Local Energy Alliance Program, and we worked with them to look at their data. They go into houses and do like retrofits to make them more energy efficient, and our main goal of our project was to just like look at the data and see what they can do better and see how it's going. So U.S. energy use comparison. This is the bottom two are the commercial and residential sectors, and you can see that they make up more than 40% of energy use in the U.S., so that's what we were focusing on in our project.
Okay, so the Local Energy Alliance program was started in 2009 in Charlottesville, and it has established relationships all over the community, and so we were very fortunate to work with them, and there have been other JPC projects in the past that have also had relationships with them. So they work with both commercial and residential buildings, trying to make them more energy efficient. Our primary focus was on the residential side, and they have a process for going through homes, which I'll describe now. So the first step is they just do a brief inspection of the home. They just do a walk through the home and see what they think would be the most likely and most energy efficient upgrade. The next thing they do is write up a report and a more detailed assessment. And after they have done this, they have a lot of contractor contacts. And these contractors are both anything from insulation to HVAC systems, just anything that a particular house would need. And so they reach out to these contractors, which have been identified in the report. And then the final step is to actually do the energy efficient upgrade. And so this can be anything from installing insulation in attics and crawl spaces, and to doing sealing on windows and that type of thing, to even replacing whole systems like water heating and HVAC systems. So while this process is very well established, we think that it has a missing piece, and we hoped to work further with that in our project.
Okay, so the missing component is the analysis. And like Aaron said, LEAP is very young, so the first 2 years, they're off to a solid start. But I thought of it kind of like an analogy to driving blindfolded. And initially, you put your foot down on the pedal and you're kind of going, and then removing the blindfold is kind of like adding the analysis component. And then you get the feedback and you realize where you are, you adjust your speed, you adjust how you turn and everything. And so this is the future for LEAP, is to add this analysis component to really determine if they're actually saving energy with these homes.
As an overview, our project goals were to collect the data and look at that, analyze it, put it into a database where we could find results that are like tangible results. And then we set it up so that it's easier to analyze the houses in the future that they will retrofit. And then another sub-project was the Better Business Challenge, which is partnership of the Local Energy Alliance program and Better Old Betty. And what that was working with small local Charlottesville businesses to do similar retrofits to their business so that they can be more energy efficient as well.
Sorry. So with the goal of collecting data and improving our databases, our first step is to visit LEAP, the LEAP house, and then we look through the cabinet files like that. But from those files, we're not looking for the data that we need. We're looking for the waiver, a waiver that from the customers that they will agree to participate in an energy saving competition. And through this waiver, we can ask the utility companies to collect the data that we really need. So what we did is we looked through the files and find the waivers of those customers, and we scanned them and sent it to the utility companies. And once the utility companies receive it, they will send us back the actual energy usage of those homes that we asked for. And once we get those data, we will put them into an Excel sheet, which is composed our major databases. And in additional to these numbers and figures, we actually look through the files again and record the types of renovations that the homeowners actually did. This information is helpful for us to as a future reference and also help us to understand the data analysis, such as why would this data will have a sudden drop or sudden increase? Is it because of a special type of renovation that they actually did? So that will help. That will be helpful for us to better understand things for that. So once we have gathered all these databases and everything, so we will proceed to our next step, which is our data analysis.
Okay, so we established a foundation for a single file database to enter in all of this data. And so it needs to be an ongoing design so that we can add in future months of data as well as future customers and expand as LEAP expands their clientele. It also needs to be user-friendly, so as the semesters go on and the new JPC team comes in, which we have for this year too, they can easily input the utility data and then it will spit out the results. So we had to design it in such a way with a dense amount of information to automatically calculate those results, so the average homeowner could see just those concrete value savings. So our first 4 homes we have here, this shows the first 6 months before the retrofits were performed, and these are this first 6 months after. So as you can see, there's a dip in the spring, and you can see sometimes they didn't necessarily save so much there, but that's because there's not too much room for improvement during the springtime because there's not a lot of heating or cooling going on, same for the fall. So as we collect more data for the rest of these years, which we're doing this spring, we'll get a full year's worth of results. And from our database, we can show that these are the percentage savings, which show promising results. And so that's good for LEAP, that's good for us, but the average homeowner, to be more convinced to perform these to get these retrofits done on their own homes, they want to see the monetary savings. And so these are the first 6 months, and this will help them to then calculate, okay, how these high initial upfront costs, how long will it take for us to pay them back through our savings. So far, these first 4 houses show promising results.
All right, so as those last slides show, our analysis showed a great deal of promising results. People are saving money, people are reducing their energy consumption by participating in these retrofits. This allows LEAP to market themselves to participants in a much more efficient way. People are going to be more willing to participate in their program, and this is especially important for LEAP right now because they are trying to expand into Northern Virginia and are even applying at a national level and kind of lobbying to get this passed on a very bigger scale. So this means that as they try to expand their program, these retrofits have an actual indirect effect on entire communities. Some of the things that we thought about were individual residents on their levels. They are experiencing more comfortable homes. A lot of these retrofits reduce moisture levels in the home, which is particularly good for asthmatics or people with breathing problems. They can also reduce carbon monoxide levels and also solve mold problems. So these people are where the places where they live and work and spend most of their time are going to be more comfortable and healthier for them. For the local economy, this program actually has direct results there too. We're keeping green jobs in the local economy. Contractors can expand their small businesses and keep that money circulating within the community. Finally, our data that showed that the reducing energy consumptions has direct results on the environment. We're decreasing the energy footprint of these communities, becoming more sustainable, and helping overall in global warming
and energy consumption issues. So that concludes our project. We would like to acknowledge some of the people who allowed us to do this project and really got us going. Professor Paxton Marshall was our faculty mentor. Helena was our graduate student advisor. And the whole JPC team really involved us from every step of the way and giving us a lot of backup support. As well as the LEAP team, who's a very engaged community partner and really helped us, gave us feedback at every step. So thank you very much.